0. Oh, there we are. So topic 3, lesson 2 of unit 1. So we're going to start off with laws of exponents. This is the power to a power rule. And according to the power to power rule, you have to multiply the exponents. So if we have a base of z being raised to the power of 5, which is also being raised to the power of 5 again, that would be z to the 25th, because all you have to do is multiply a power times a power. All right, so we have base b. B to the 7th to the 2nd is b to the 14th. M to the negative 8 to the negative 3rd is m to the positive 24, because we have negative 8 times negative 3 is positive 24. All right, so this time we have multiple bases. So the first thing I'm going to do is list out all of my bases. And then we have exponents. So x to the 2nd is raised to the 8th. That would be the 16th. Y's to the 4th to the 8th. That would be 32nd. So think of it as like the distributive property. Whatever's on the outside has to be done to everything on the inside. So m to the 3rd to the 8th would be the 24th. And I guess you're going to have to watch the video because it's kind of hard to see if that's a 32. That's what that is. That's a 32. 3x squared to the 4th. Okay, so now one thing different about this question is you notice that this one has a coefficient. Coefficients have to be raised to that power, and that is the most commonly forgotten thing. 3 to the 4th power means 3 times 3 is 9, times 3 is 27, times 3 again is 81. So 3 is a coefficient. Coefficients have to be raised to that power. Then keep the base the same. 2 to the 4th is the 8th. All right, so once again, we got a coefficient raised to the 6th power. 2, 4, 8, 16, 32, 64. So 2 becomes 64 because it was raised to the 6th power. X becomes x to the 18th. And y becomes y to the 6th. Because remember, anything that doesn't have an exponent is to the 1st power. All right, so that was the power to a power rule, which states you multiply the powers in order to find the answer. All right, great. So this lesson is about discovering how things can be the same with different powers and finding what could the pattern be. It's all about patterns here. So we're finding like, well, if this is 64 and this is 64 and this is 64, so that means that 2 to the 6th is the same thing as 4 to the 3rd, which is the same thing as 8 to the 2nd. So what you should have noticed in this lesson is that the base of 2 is always going to be twice the exponent as base 4. So I'll prove it to you. So if we look to find something else that is also the same, so I see something here that's the same. So 4 to the 8th is the same as 2 to the 16th. Because you'll notice that the exponent for 2 is always going to be twice that of 4. If you're going to look from 4 to 8, you're going to notice that 8 always has an exponent that is 2/3 of 4. And the only other thing that's going to be true is 2 to 8, base 2 to 8. You're noticing that the base 2 always has an exponent that is 3 times bigger than 8. So the point of this lesson is for you to understand that different bases can be equal. And that gets us to the idea that we can then change things from one base to another. And everybody had a different sheet and answered different questions. But basically it was the same premise as what I just talked about. So talk about the homework now. Using what you have learned, how would you solve 25 to the 3rd is equal to 5 to the x? Well, just like I just talked about, we can change 25 into 5 squared. 25 is the same thing as 5 to the 2nd power. But there's also a 3 there, so you have to leave the 3 there. I'm going to leave it in parentheses. Equals 5 to the x. Now, the first thing we need to do is get rid of this parentheses. 2 times 3 is 6. So this becomes 5 to the 6th equals 5 to the x, which means then we can cancel our bases, which means x must be 6. There's your answer. Question number 2, using what we have learned, how would you solve the equation 9 to the 4th equals 3 to the x? Well, first ask yourself, can you make the bases the same? Well, I can. This one is 3, so I'm going to leave that one alone. But 9 is the same thing as 3 squared. But there's also a 4 there, so you got to leave it there. So 3 to the 2 times 4 is 3 to the 8th equals 3 to the 6th, 3 to the x. And then cross off your bases, and then you've got x equals 8. All right, question number 3. Using what you have learned, how would you solve the following equation? 10 to the x is equal to 1 over 1,000 to the 5th power. So we've got different bases again. We've got 1 1,000th. So I'm going to use my negative exponent rule of my laws of exponents in order to convert 1,000th to using base 10. Well, 1/10 would be 10 to the negative first. 100th would be 10 to the negative second. 1,000th would be 10 to the negative third. And then keep that 5 there because that 5 can't just disappear. So this is still 10 to the negative third to the 5th power. Now, I put parentheses around the 5, but honestly, I should have been putting parentheses around this. So you know what? I am going to do it the correct way, even though it's going to be the exact same answer in the end. So it's going to be 10 to the negative third. Okay, pen. There we go. So I just changed this into this with a 5 on the outside. Now you can see that it's going to be the power to the power rule. 10 to the x is going to stay the same, is equal to 10 to the negative 15th. Cross out your bases, and that means x must be negative 15. Done. And last question here, and let me move myself. I'm going to move myself to the middle where I never move myself. Hi, how's it going? Oh, maybe it's time to tell a joke. Why did the math book go to the guidance counselor? Yeah, I know I'm full of bad jokes. Give me time to think. The guidance counselor because the book was it was full of problems. That's the reason I went to the guidance counselor. So here we go. 27 is the same thing as 3 to the third power. 3 times 3 is 9 times 3 again is 27. 3 to the third power. So 27 is the same as 3 to the third power, but then there's also an x on the outside. Equals 3 to the x plus 6 power. All right, so let's use our power to power rule here. So 3 to the 3x power is equal to 3 to the x plus 6. Cross off your bases because they're the same. So that means 3x equals x plus 6. Subtract, use subtraction property equality. Yeah, we're using a lot of steps, but none of this is really that difficult. 2x equals 6. Divide both sides by 2. I kind of ran out of space here. So that means x is 3. 3 is the answer. Okay, great, awesome. I could prove that by putting 3 back in for x and solving. And using your graphing calculator, you just do 27 to the third power. I showed you how to do that yesterday. All right. Have a wonderful day, and let me know if you have any questions.